Oh, I forgot to prepare some. One moment. Factorize. Yeah, you come. Yeah, it's just the same. You count the cofactors of each element and put it outside. That's as simple as that. Is that right?
Mm-hmm.
Relatively speaking, this is not a challenging question. Is it challenging? Do you find it challenging?
I'm not sure how to do it.
Or you just use the cofactors. Can we start 2 by 2? Just to demonstrate these factors, cofactor. For example, if you have, do you remember when we started the relativity? Did we mention that? So if you have the, for example, if you have the 2, 6, right? You got 4 and 12. Can you see the cofactor among these 4 numbers? Use your algebra.
Mm-hmm.
Can we rewrite that? 2 multiply 1, can you see?
Mm-hmm.
2 multiply 3. Is that what you're talking to? 2 multiply 2, can you see?
Mm-hmm.
2 multiply 6. So in this case, can you see that cofactor? It is the same as we did with a single factorizing, you see?
Mm-hmm.
If that is so, what can we do? You can put these 2 outside, you see, the cofactor.
Yeah.
Is this what are we talking about? Solved. This is cofactor.
Mm-hmm.
Of course,
is that all we have to do?
Oh, yes. If that is the question, if you just ask me how to factorize a given matrices, a matrix, that's how to do it.
Mm-hmm.
If there's no, for example, if there's no factors, what can we do? We just, if there's no fact, for example, if we just continue, you say, well, there's no cofactor now. If there's no cofactor, but if we do want to continue factoring, what can we do? For example, if you want to put a 3 outside, what can we do? We just divide it by 3. Can you see?
Mm-hmm.
So this is also part of our cofactor. Factorizing, can you see?
Mm-hmm.
This is how to factorize matrix. Any example you want to a question belong to this question, belong to this operation?
No, it's not in the textbook, but it's something we have to know apparently.
Oh, from the syllables, right?
Yeah.
Yeah. Yes, it is not a big deal. It's not big compared with say inverse. Do you know how to find the inverse? Is that required? Do you need to find the inverse giving
1
A?
over AD minus BC.
Yes, that's 2 by 2, right?
Mm-hmm.
That's 2 by 2. So 2 by 2. So how about 3 by 3? Yes.
I'm not sure.
Yeah, it probably not required. If that is, yeah, are you talking about this formula A, B, C, D, right?
Mm-hmm.
In this case, can you write the formula for the inverse? That's more challenging than find the cofactors.
I'm not. Oh, for that one, it's
You divide
A negative.
you determinant, right?
Mm-hmm.
Or they just use simple notation. The determinant, we just many textbooks just use this bar, just like absolute. It's called determinant, right?
Mm-hmm.
And then another matrix here is changes A and D, right?
Mm-hmm.
A and D, you change the 2 elements and put the negative sign here. That is what the formula say.
Mm-hmm.
But do you know how to derive this formula?
No.
Yes. Do you want to know?
Mm-hmm.
Yes. Yeah. Let's just spend a few minutes to discuss to derive this formula. Otherwise, you have to memorize that. Yeah, when you study the matrix, it's, if you know how to derive that before. So when we talk about the inverse vectors, we know that the we can build inverse vector. So basically, we know that by definition, so the inverse vector multiply the inverse matrix multiply the matrix were equal to identity matrix, right?
Mm-hmm.
So for 2 by 2, this identity matrix can be simply written as 1, 1, 0, 0. Do you understand?
Mm-hmm.
So if we want to know that what is if we want to know this inverse function, inverse matrix is, can we call this is alpha, beta, gamma, and delta, and the matrix is A, B, C, D. You see, A, B, C, D must be equal to the identity matrix. You see.
Mm-hmm.
Now, based on this equation, based on this matrix equation, how many equations can we build? Before that, can we finish this? Product? Can you tell me how to find the product of these two? The left hand side. Can you finish this one? Use the product multiplication rule. Do you know the multiplication rule? Did you? Yes, plus, that's right. Do you mean the 1, 0? Did you say 0? Where's 0? Where does 0 come from?
Yeah.
No. Just focus on the left hand side. Forget about the other side. Okay. Just finish the product, please. Multiplication first. Yeah. Yeah. That's right. Okay. Because this equation is, these two matrices must be equal according to definition. Can you build a full equation over here? Because we have we have four unknown, alpha, beta, gamma, delta to be solved.
Oh.
Yep, first equation. Cool. Okay, can we solve alpha, beta, gamma, delta in terms of ABCD? So ABCD is given, are given.
What is ABCD?
ABCD is given, are given. We just we
Oh,
rewrite.
then we could solve it. Yeah.
Yeah. Yeah, in principle, you should be able to solve that.
Yeah.
Do you want to try? Can we start from this simple equation? Because got 0 is easier. Can we find this relation first? Okay.
Oh, we're trying to solve it the other way
yeah,
around.
with the other, we need to solve the alpha beta.
Mhm.
Divided by b, right? Divided by
Mhm.
b. Okay. Good, good, good. Can we just use this to solve another? Can we just use? Can we substitute these two results into the first and the last equation? To solve the beta first, can we? Yep. So beta is solved.
Mhm.
Principle. You can continue here. You can we can we use some proper? We want to save some space. Can we solve the beta directly from here? One take something, right?
Mhm.
Or you can put this up to you. You can put the beta on the other side. Okay. Oh, that is beta, right?
Mhm.
That's equal to beta. Did you see that?
Yeah.
Okay. Okay, beta is solved. How about alpha? Alpha is related by, we should be able to work out alpha first. Can we go to alpha? Yes. This is gamma. Sorry, this is gamma. Yeah. Can we work out alpha first?
Mhm.
Yes. Good. Multiply the negative. Yes. We run out of space. Can you write your result here? Can you write your simplified result over here?
It's one
Yeah.
for the CB.
That's simple as that.
I think so.
No, denominator got a two term. How can you as simple as
Because
that?
when you times negative,
You cancel B, got a
Because-
BC.
because b times negative b over b is negative b.
Double check. I'm not sure. Can we double check that for you? So we got 1 over negative dB, right?
Mhm.
Oh, my pen stopped. Negative dB multiply. We put a negative sign here. Okay. We put a D here. We put a D here. And the B will be that be positive. So that we multiply the B, you see, and plus BC. As a result, we got negative D. We still got negative D. We got yeah, too many negative. Can we just multiply negative here? So this is first become positive. Can you see? D minus BC. Can you follow me? My answer, my answer is different from you. Why?
Oh, right.
Can you see? And this B cancelled. Do you agree? This B cancelled. Can you double check that?
Yeah, I think I just did it wrong.
Okay, good. Okay. Can we copy this result over here? The correct answer. Can you write your correct answer here? Okay, good. We solved two unknown. Okay. Doesn't look correct. How can we just double check the beta? It's the first equation, beta alpha is solved, alpha equal to negative alpha next to BD divided by B. Yes, that's correct. Back to this equation, we got alpha is replaced by A. You forget A. A, yes, that's right. We got A here. That's right. That make a balance. So we still got A here. Can you see? We got A here as well. Can you see? Yeah. Yeah, that's better. Oh, negative.
Oh, right.
AD minus BC. AD minus BC. Yep, that's correct. So that is how to solve. If you wish, you want to stop, you can stop. But that's how to solve that. Can we solve the B? Can we simplify the B? Sorry, beta. So beta can be simplified by just multiply the B. Can you see? We multiply B here, and that becomes BC. Take AD. Can you see?
Yeah.
All right. So that is how to solve that four unknown. Do you want to continue or want to stop? If you get bored, we stop.
Yeah, I think that's good.
Yeah, you can continue. If you wish to continue, you can use substitute the gamma into this equation to solve the delta first. All right. Go on.
I also wanted to learn about de Moivre's theorem.
De Moivre's theorem, yes, that is totally different. De Moivre is a complex number, right? Yeah. Complex number, change the subject, right? So when you start with a complex number, we have used we have used a coordinate, right? So that is how to denote both the real and imaginary number. So that is similar to Cartesian coordinate, but this part is a real number. You see, and this part imaginary number. Okay. So the whole area is called a complex plane. This plane is called complex plane. Like this whole page, can you see? In which any complex number can be written as Z, can you see? Which can be written as this is A, this is B, okay? This, by the way, the unit here is called I. So the unit is I, 2I, can you see? This is 1, this is 2, and this is negative I. Okay, and this real number, horizontal is a real number. Okay. Okay, so that is how to decode. So we can denote this number. You can use this either. You can use this A multiply I and B. That is complex number. How to denote a complex number? Can you see that? Alternatively, you can also use a two variable, which is using this, take advantage of this triangle. You can use this distance from the region, from the origin, can you see? And also you can use this angle. Okay. So this is distance R, can you see this distance R? Okay. So therefore, the same complex number can also be denoted by these two variables, theta and beta, you see?
Yeah.
And in general, we prefer not use A and B, we prefer to use X and Y, you see? That's I, you can use Y, doesn't matter. So X, Y is okay. So because with x, y, we know that in this triangle, x is equal to r cosine theta. Can you follow me?
Mm-hmm.
And what is beta? What is y? In this triangle, so this is y, this is x.
Sine.
Yep, that is sine theta. So it's called a polar coordinate. Okay, so when you use theta and r, this coordinate is not Cartesian, it's called a polar, you see, polar coordinate. So if you put r here, if we factorize r outside, we can get this notation for the complex number, cosine theta plus I sine theta, okay?
Mm-hmm.
So in short, the complex can write down here, the complex number can either into this into these different forms. A complex number can also written as this form. Can you see?
Mm-hmm.
The de Broglie theorem is dealing with what would happen if we multiply. So if we multiply, you have to have called z squared. Have you studied this part yet or not? It's just a preview, or you have done that?
I've done it, but I don't remember it.
Yes, go on. Can we try to work out the square of that? Use algebra. This is a good opportunity to practice your algebra.
I think it was.
Oh, you can start. Yeah, you can start there. Okay. Yeah, can we use algebra to find the formula for the So when we started this part, the important identity is called I equal to root -1, all right? That is how we introduce imaginary number here. That's unit for imaginary number.
Mm-hmm. Is that it?
Let's check. Oh, it's not as simple as that. Where is I square? Oh, you got I square here. Okay, good. Got the full term. Did you got a full term?
4 because it would be 2.
Yeah, 2. So it's a cosine.
Yeah, I
Let me check.
did it wrong.
That's right. Yeah. All right. So can we put this? Can we put the real part together? Can you put this cosine square and sine square together? You need to use some little bit of trigonometry to simplify this. Can you put the real part? So this what I mean the real. So this is real. This is real. Can you put the real part together? And that another is imaginary. Can you see this is imaginary?
How do I put them together?
Just write them together. So I'll show you. R square cosine square theta take sine square theta. Okay. Plus use your knowledge. Can we simplify this a little bit? can we simplify 2 sine theta and cosine theta? Can we simplify this? Simplifies as the sine double angle. Do you remember this formula?
Mm-hmm.
You do? Yeah.
Mm-hmm.
Can you do it? Can you do that? So you got, can you write I first? And sine 2 theta, you see?
Mm-hmm.
Now, the rest of work is to have, how do we simplify this as a double angle formula? Do you have double angle for cosine? Can we just recall what is a cosine 2 theta? Or by the way, can we start from basic? What is cosine alpha plus beta? What is formula?
Cos alpha cos beta minus sine alpha sine beta.
Yeah, can you write down? You can write. And then from here we can derive our formula 2 theta. Okay, you write this first. And then we will derive this formula. Yep. So based on this formula, can we derive the double angle formula for cosine? So in other words, from here to here, we just net alpha equal to beta. You see? Equal to theta. We just do this variation. Because we are looking for, we suspect this could be give us a double angle formula for cosine, okay? That's why we go backward. We're trying to find a formula for double angle cosine.
Mm-hmm.
Can you do that? Do you know how to do that?
I don't know how to simplify it, but
You forgot how simple. Well, we just simplify. Can I
oh
show
wait,
you?
no, it would be cos
Theta, yes. Square, take just one inch away to your results. Okay, our guess is correct. Do you agree? Indeed, this can be rewritten as double angle. So that's very useful in our case. Okay, can you simplify it now? Can you simplify this? We are searching for pattern of the complex number. Well done, well done. So let's look for pattern in mathematics. We are looking for pattern. We see a square here. Can you see? We see square here. We see 2 here, rather. We see 2 here. We see 2 here. Can you see? Can you see the 2 are consistent? If we wish, we can put the number here. Can you see? This is 1. This is 1. This is 1. This is 1. Can you see the pattern? Do you think you have seen the pattern?
Yeah.
Then let's jump to the conclusion. What would be the formula for the complex number to a power of n? Can you write this? Can you? Yes. N could be any number, 10, 11, 20. Yes. Congratulations. So that is the Moore theorem. Got it?
Yeah.
Mr. Moore, can we highlight that formula? Because that is that's very important. Of course, here we just simplify. We didn't check that. We just use this called mathematical induction, right? So we prove the formula. So this formula is what you ask for, and we can apply this formula in different places. Okay. So that is the answer to your question. Next, the more.
Yeah. I think there's also that there's this one formula.
You can write, I can go to new page. You can write any question we can discuss.
How do we use binomial expansion?
You're hopping. Jump to
Yeah,
you're to
use,
another country. We're from American to Europe now.
Yeah.
Right? It's a binomial. Okay, and let's also tell me, do you know the binomial formula in the first place? That binomial theorem in first place. Can you write down here? If you have alpha plus beta to the power of n, can you write the sigma form of the binomial theorem?
Um,
Or you can look for your formula sheet if you wish. You don't have to memorize that.
my formula sheet doesn't have the binomial.
Oh, don't? Well, you have studied binomial distribution in probability.
Mm-hmm.
Do you know this notation? NK, do you know this notation?
No.
K from, have you studied probability? Statistic? There's a binomial distribution, famous distribution called binomial distribution.
I've studied binomial distribution, but I haven't seen that formula used.
Well, that is a formula. We can write down formula. That's the formula K, can you see?
Mm-hmm.
That's the beta and take K. I read the binomial formula for you, okay? If you had the probability complement event P plus Q, okay?
Mm-hmm.
And if you work out this n times, okay, that is how many times you play, how many trial you have. So that's that form will be the same. So that formula will be the same. So that will equal to K from 0 to n. That is a binomial distribution probability. You can see.
Mm-hmm.
That is probability is a K. Can you put it as a K here? And I write down the whole full formula. So that is I probably use this different notation. It's a K, N, and P. All right.
Mm-hmm.
So in other words, so where we just combine these two subjects together. The probability, or sometimes put R here, probability, you trial something n times, right? How many times you will see the success? P represents success, right?
Mm-hmm.
Success. Q represents failure, right? So that is a probability can written as this form. You see, N, K. Can you recall this formula now?
Oh, yes, yeah.
That is the origin of binomial distribution. Got it?
Mm-hmm.
So with this is a very important, this is a binomial distribution, okay? Binomial probability distribution. I'll just say distribution, binomial distribution for short. Okay, any question? So that is related. You can see this, but this is the first one. So this one is called the binomial. So this formula is called the binomial theorem. And that is a binomial theorem. It is a different idea. It's related. Do you know this form? Do you know this formula? It's called the combination formula. It's called the combination formula. Combination. If you want to expand this binomial theorem, you need to know this formula first. You forgot? Have you forgot?
Which is the combination formula?
Do you know this factorial?
No.
Oh, you haven't studied this. How did you study binomial distribution? Have you seen the formula before? Combination, permutation. Have you studied this formula before?
No.
How can you study binomial theorem without study this formula? Perhaps this is a general formula, okay? If that is the case, can we go to something special, all right? Can we go to something special? So this is a basic formula for binomial, is binomial theorem. But what we can do alternatively, we can use the Pascal triangle. You know the Pascal triangle? You know, have you heard of Pascal triangle?
Yes.
Yes, that is one thing. That coefficient is actually this number. So this is 1. Do you remember that one? You got 2. You got 3. Have you seen this triangle before?
Yes, I have.
Yes. Why do we need this number? Tell me. Do you know why do you need this number?
I think it's used in the binomial theorem.
Yes, that is a coefficient. So that is a coefficient. I tell you this one by one. So these coefficient, these coefficients go on forever. So this coefficient, they are all the coefficient for the binomial theorem. Coefficient CIENT. So this one corresponds to n equal to 0. Can you see n equal to 0, n equal to 1, n equal to 2. That's the degree of the binomial. Is n equal to 3. This is n equal to 4. Okay. Of course, this continues. If you just start from beginning, so basically we are looking for alpha plus beta to the power of 0. So what is the answer?
1.
It's 1. Okay, I just make this formula here. How about alpha? Yeah, that's to the power of 1. It's just alpha plus beta. Can you see? Okay. We put this coefficient. I coloring this coefficient here. Can you see? Although we know we don't have the right one, inconsistent with this pattern. Can you see? Can you see the first 2, 3 number now? That is origin of this Pascal triangle. Now, do you remember the formula? Of course you remember. So what is alpha plus beta square?
1 alpha plus.
No, we got alpha square. Can you see? Plus 2. Can you see? We plus 2 plus 2 alpha beta plus beta square. Do you agree? So in this case, the coefficient is 1 to 1. Can you see the pattern now? 1, 2, 1. Can you see that?
Yeah.
So you can continue forever. For example, in this way, we don't have use any formula. We just follow this pattern. You can try. I give you a try. What would be the formula for alpha plus beta to the power of q? Can you write the formula? Can you? This is called a polynomial. First, the highest term for alpha is q. Yes. 2. Are you sure it's 2? Why don't you look at the triangle, Pascal triangle on the left-hand side? That triangle was introduced for people to build expand this binomial without actually do the algebra. Now, to simplify, you forgot the beta. You see, where's beta? So this is beta. Remember, these two numbers will always give you 3. Can you see the sum of these two numbers will give you 3. And here we have put the alpha. Can you put the alpha here? You see?
Yeah.
So the 3 number will be identical. Can you see? Of course, you this time you copy that. You just read that number. Can you see? Give you some challenge one. Can you work out this 4? How about alpha? Alpha plus beta. How many terms, by the way? Another pattern. How many terms for the power to the power 4? How many terms? Here we got 1, 2, 3, 4. 4 terms. We got 3 terms here. So how many terms?
5.
Yes, that is n plus 1. Can you see? So from here we can see that altogether you got 3 plus 1 term altogether. Yes. Yes, that's right. If you haven't studied the combination formula, that is how you work out that coefficient for binomial. All right. In other words, if we just recall our formula here, so the if you just put this binomial formula here, so alpha plus beta to the power of the n will equal to sigma. This is coefficient. Can you see this coefficient? nk, can you see? So that k from 0 to n. That's why they have altogether got an n plus 1 term, right? Alpha to the power of the k, and this is beta to the power of the n take k, okay? So if you combine this formula, you know that the first term here, so that I write down here, so this formula, the first formula here is when n equal to 0, can you see? And k equal to 0. Because k is from 0 to n, can you see? How about this number? How about this one? In this time, n equal to 1, can you see?
Yeah.
In this case, k is equal to, from 0 to 1, k is equal to 1, can you see? And also, this number is also can be denoted as n equal to 1, k equal to 0. Does that make sense? So that is why, in general, we use, actually, this also is contribution by Isaac Newton. You see, so this formula is derived by Isaac Newton. So basically, we can either use what we call the Pascal triangle to work out the coefficient. Okay, of course, you can imagine if n getting large, if the n getting very large, it's not convenient, all right? For example, if n equal to 20, you would take ages, right?
Yeah.
So that is why we have eventually used this formula to calculate this one. It's not complicated. I show you how to do that, all right? So this is a general formula, okay? I can show you why the special case. What would happen? Can we start from the, bear in mind, so what you need to know is that the factorial. So in this case, for example, it's called the factorial. This is called the factorial. So what is factorial? That is, say, for example, say the 3 factorial is simply equal to 3 multiply 2. Can you see? Multiply 1. That is 3 factorial. So n factorial is simply equal to n multiply n plus minus 1 multiply n minus 2. until 1. You see? That is formula. Once you know this formula, can you calculate that 1? And you can do something. And you can say if n equal to 2, right? K equal to, let's do something complicated. So if n equal to 3, k equal to 2, can you work out this number based on this formula? Yeah, and I know you are quick learner. This, if you haven't learned this part, I just want to see how fast you can pick them up. Yes, that's right. Okay.
That
It's
is that
fine.
right?
Yeah, go on. What is number after this division multiplication?
Mm,
3, right?
yeah.
Okay. Let's identify where did we get this idea? Where can I find this 3? Okay, tell me, when n equal to 3, how many k do we have? When n equal to 3, based on this formula, when n equal to 3, how many k do we have?
K.
Yeah, k is starting from 0. Can you see? K is equal to 0.
Oh, then it's just 1.
No. K equal to 1. Can you follow me? K equal to 2. I'm counting now.
Oh, right. K
It's
is
k
3.
equal to 3. So there are 4k. Can you see?
Yeah.
So that is what is this means from. So this summation means from k equal to 0 to k equal to n. Can you see? So therefore, this is 3. Can you see this is 3? So if I use our notation here, in our case, n equal to 3. Do you agree? K equal to what? K equal to 1. Well, we didn't calculate that. But what we calculate is this part. Is 3, 2. Do you agree?
Yeah.
So they are equal. Can you see? Is that interesting?
Yeah.
Also, no, we can check. We can check. Okay, if we are not sure, can we check that if this is true? 3, 1. Can you use the formula to check? Both are equal to 3 according to Pascal triangle. But are they true? Are they correct? Ah.
It's not correct.
No. Double check your formula. Why this is 1? Did you say this is 1?
Oh, right.
Oh, try again. Okay, fine. It's fun, isn't it? Right?
Yeah.
It's better than found the cofactor of matrix, right? Yes, you're right. You agree? Are you surprising? And Newton come out with this general formula, which is covers not just the finite number of this Pascal triangle, but cover everything, even n equal to not huge number, thousands, millions even.
Yeah.
So that is a fun part of this triangle I just highlighted. Of course, everyone started this Pythagoras theorem from the Pascal triangle because that's visible. Can you see? So this triangle is visible like a pyramid. Can you see? You can continue forever almost. Can you see? However, if we use general formula, that's why we always derive the general formula. See, if you know the general formula, then we can treat any term. Well, let's try to some problem solving. Can we? Because you have done that. Are you sure you have done this part?
A long time ago, I think.
Oh, long time. Year 11, right? Okay. Let's do something real. Go to example. So if we have, so what? Okay, given the question. Here's a typical question of binomial. So given 2x plus y to the power of the let's go to the 7, all right, 7. So what is determine the coefficient? So determine the coefficient. You know the coefficient? Coefficient of x5 term. The term contains the x5. You want to try? So we need a number for this coefficient, right? So the coefficient is a number. So this could be assuming certainly that one of the term contains this one. Oh, you don't want to use the general formula. You want to use.
Oh wait, I can just use the general formula, can't I?
Do you remember that general formula?
Yeah.
Okay. I write down here. So alpha plus beta n equal to sigma nk k from 0 to n multiply alpha k beta n take k. Yeah. Yeah, the coefficient is just that that combination formula. Do you remember? So this is coefficient. Can you see?
Yeah.
Good idea. Yeah, good idea. Yeah, this is a term we are looking for. We need to find the coefficient of this term. Yes, you are right. So that is a term we needed to find out this coefficient. That's right. The sum of 5 and 2 is 7. Nearly. Yeah, or you almost get nearly get there. What is coefficient? No, not that's right. That's not right. No, not right. So this 44 has nothing to do with this formula. Can you see? We have used this formula for coefficient. Did I mention that?
Oh, right.
Yes.
Oh, wait.
64 is something extra we have to take into account.
Okay, so
can we use this notation? We will not use this notation. That is what is notation? NK. Can we use this notation? Yeah. That is coefficient. This is original coefficient in the binomial theorem.
No, wait, that's not what n is.
Can we do it again? Yeah, n equal to 7 in our case. So from here we say n equal to 7. Do you mean the 2? What is this term? 2 minus 1 or 2?
Because 7 minus 2. Oh, 7
2
minus 5.
2 minus 5. Okay, okay, that's right. That's factorial 2. Oh, yes, you're right. Yes. Yes. That's right. $21. Yes, that is original coefficient. So what is coefficient now?
21.
No.
Do we have
You-
to times it by 64?
Yes, that's right. That's why this is a trick here. Can you see? This how to that question is how to incorporate these two in your coefficient. Otherwise it's always 21. Okay.
Mhm.
If the question is alpha plus beta to the power of 7, okay, so the alpha fifth term and the beta square is 21. Okay.
Mhm.
You know what I mean? So that is
Yeah.
a typical question in this context. How do we work on that one?
Mhm.
Yeah, it's huge number. You have this calculator. Okay.
Yeah.
Wow, we have visited a lot of countries today.
Yeah, we jumped a lot.
Yes. Okay. See you next time.
I'll see you on Friday.
Okay. Okay.
Okay, thank
Good.
you.
You are welcome. Goodbye.
Bye.